A lot of opportunity, it looks like.
That's right. That's right. In brief, Invest America is a federal legislation creating an investment account at the time of birth for every child born in America. The biggest impact Invest America is going to have, according to me, is independence, away from dependence from our state, and making every child in America an owner of our economy. Brad, I have the great honor of calling you my mentor, coach, and partner. Thank you so much for doing it. Please join us.
It's great to be here. Thanks for having me. And, a special thanks to Dr. Goel for greenlighting the class. I think it's a really important one. In a lot of schools today, in particular colleges on the East Coast as well, there's this, people don't really know what to do with AI. And I say all the time, you got to make yourself bionic with AI, right? Like you can't consume enough AI today. Because it doesn't, it used to be you go to this school, you get a job with a place like Grok or Altimeter, and today I don't really care where you went to school. I want somebody who shows up and delivers abnormal value, bionic value, right? And the way you do that is going to be leveraging the latest technology. So I'm glad that you are enabling the students to sit at the intersection of such important topics. I'm going to introduce Sunny, and then I'm going to share a couple slides, and then I'll invite Sunny up. But, I was thinking, Sunny and I have been great friends for a long time. We're going to play poker tonight in the all-in poker game here in Silicon Valley. So we're buddies inside and outside of work. But I was thinking about the introduction, and then I asked ChatGPT and Claude to give me an introduction. And, ChatGPT's wasn't great, to be perfectly honest, and Claude's blew me away. So I figured I'd just read to you, what Claude had to say about Sunny. So our next guest is a serial entrepreneur who apparently can't stop getting acquired by bigger and bigger companies. And honestly, the trajectory is incredible. He co-founded Extreme Labs, a mobile development shop acquired by Pivotal. Then he co-founded Autonomic, a smart mobility platform acquired by Ford, which he became the VP running FordX, their internal innovation lab. Then he co-founded Definitive Intelligence that was acquired by Grok, where he became president and helped launch Grok Cloud. And then NVIDIA bought the platform, of course, recently for $20 billion, their largest acquisition ever. So if you're keeping score at home, Pivotal, Ford, Grok, NVIDIA, the man's career is basically a SPAC that only goes up, according to Claude, unlike Chamas, okay? He has a computer engineering degree from the University of Ottawa, which proves that even Canadians can disrupt things when they put their minds to it. Please welcome Sunny Madra. So I like to share a couple slides to set the context for the moment that we're living in. And inference, the conversation we're going to have today, is really a subset of this important conversation. But this is global GDP per capita over the course of the last 2,000 years, right? And if you look at that, you realize that basically for 1,800 years, nothing happened. It was survival, right? There was no excess productivity from a fixed amount of labor and capital, right? It was what we could use to survive. And then all of this stuff starts happening in the 1800s and 1900s. The number of years it takes to double GDP, and I like to say GDP is what creates the excess in life for enjoyment, right? It's beyond survival, right? The surplus that we all have. And so the number of years it takes to double GDP, right, has plummeted, and now we're doubling global GDP, or you might think of it as quality of life, every 25 years. But you may say, well, Brad, what does GDP have to do with anything? Well, it has to do with everything. So what happens when you have higher rates of GDP? You have lower rates of poverty. You have higher rates of basic education. You have higher rates of literacy. You have more democracy, more freedom, higher rates of vaccination, lower child mortality. So it turns out that innovation in and of itself is a societal good, and it happens to be correlated and accelerating. So technology as an investor has gone from 5% of global GDP to about 13% of global GDP. And if I asked you guys 10 years from now, are we going to be at below 13% of global GDP or above 13% of global GDP? I think you would all say that technology as a percentage of global GDP is going to be a lot bigger number. We're sitting in the heart of Silicon Valley. Technology out-earns non-technology. So the dotted blue line here is, this is the NASDAQ, has compounded earnings per share at 15% for the last 10 years, compared to 6% for non-tech companies. So why do technology companies tend to be better investment than non-tech companies? Because they compound their earnings per share faster. Again, I think will be accelerated by AI. And of course, AI is going to massively accelerate all of this, because when we look at all the knowledge work in the world, the TAM for it is measured in the trillions. Demis said it well. It'll be 10x the impact of the Industrial Revolution, but happening at 10x the speed, probably unfolding in a decade rather than a century. So I think that is the context. Like, what we're doing here and the acceleration that will come with AI should be something that's better for all of society. We're going to have to talk about the guardrails and the societal change we're going to have to make to be that. But sitting at the very root of all of this is compute. You know, you guys all know that the atomic unit of AI or intelligence is the token, right? And there's nobody better able to talk about the production of this atomic unit than Sunny. And so Sunny, I want to kind of go back in the Wayback Machine a little bit. You know, tell us what Grok is, right? And what your observations were in 2023 and 24 about what was going to happen with inference.
Yeah, it's a little bit of a quick background. So Grok was founded by Jonathan Ross. Jonathan Ross was the creator of the TPU at Google. And Jonathan Ross's background is interesting. He was a high school dropout, not because he couldn't complete it, because it was like probably too boring for him, and went straight from being a high school dropout and probably complete his GED or something, and went straight into like a PhD math program at NYU. And then gets recruited into Google, and like every great engineer over the last 20 years was made to work on like ad optimization or ad testing, which is terrible in some ways. But what he did was he listened to a talk by Jeff Dean, and Jeff Dean had come in and basically said, hey, good news, bad news. Good news, we've found an algorithm to solve automatic speech recognition, which could be useful in many places. Bad news, there's not powerful enough compute, so we can never run it. And Jonathan took it amongst himself to come up with a design, and coming, from a completely different area, design using an FPGA for the first version of what became the TPU. And then ultimately, Jonathan left Google because he thought the rest of the world should have this. It shouldn't just be embedded inside Google. And so he left and started it. And so quickly, what Grok is, and it continues to be inside NVIDIA as well, it's a chip that's designed with a data flow architecture. And what makes it very significantly different than any other computer architecture is that it's fully deterministic. So hand in hand with the architecture is a compiler, and a compiler which predetermines where all the calculations are going to happen. And that last bit is really important because the underlying thing to any AI problem and token generation is lots and lots of math. And that's why we're seeing this compute explode. And I implore everyone to go look at the following. We talked about one of Brad's great investments, Snowflake. Snowflake is a database retrieval company, right? And so you have to go get a record and bring it back. And if you look at the number of cycles it takes to do that, and compute cycles, you can really see, and it's not a really large amount, but you look at the number of tokens it takes to generate, number of compute cycles or flops it takes to generate a single token. It's mind-boggling. And the best way to think about it is it's usually the parameter size of the model times the context length squared, right? And so that's for each token. And you're doing something, you have lots and lots of tokens. So we're in this era where we have this incredible technology, but it's incredibly compute intensive. Several orders of magnitude larger than any other computing paradigm we've had before.
You're at your own startup, right? You have a conversation with Jonathan about merging. I was an investor in Cerebras, yep, which is also building a fast inference chip. Grok was building a fast inference chip. These two companies had been in existence for upwards of 10 years. Yep. And the extraordinary thing is, like in year 9, they're both fighting for survival. They're not thriving, right? Like they're building for a market that didn't really exist. okay? But you saw something. You know, Jensen came on my podcast, BG2, and he said, everything just changed. I said, what do you mean? He said, inference time reasoning. He said, we've gone from pre-training models to inference time reasoning, and inference is about to 1 billion X. So not 10X, not 100X, not a million X, it's gonna 1 billion X, and our systems of compute are not designed for what's coming. I remember you and I had a conversation, and shortly thereafter, you helped broker, you know, kind of this vision for Jonathan that said, Jonathan, I think I see your future more clearly than you do. So tell us about that moment.
Yeah, I think, you know, at that moment, a couple things are happening, right? So the market had been dominated by NVIDIA because NVIDIA is what the researchers use to create the models. And so naturally, in part of creating a model, inference is the forward pass of training, right? In the back prop, that's what's different. And so you're always doing inference when you're creating models. And so it's very natural to just run it on the same hardware that you've created the model on. And so one of the things that, you know, we saw with the Grok architecture was that we could complete inference much more efficiently, right? And so if you look at our V1 chip, which we, you know, put into the cloud, and I'll get back to it in a second, that's a silicon designed in 2018, silicon from 2019, 14 nanometer, and super competitive against Hoppers, right? Which is, you know, 5 generations newer in terms of silicon technology. And so really what we saw was, we thought it would be very difficult for convincing people to buy our hardware and use it. But if we built a cloud and put it in the cloud, developers really don't care, right? If there's an API. And developers, you know, we've seen they're quite fungible there. So our big insight was, take these things, start putting them in the cloud, run the data centers, and make them available via an API, and make the best open source models available for everyone. And even including OpenAI models, like OpenAI had Whisper, which was open source from the beginning. And so we had put a lot of those models there, and that's what really took off. And we launched the cloud, and within a few weeks, we went to a couple 100,000 users, and today it's like something like 4 million users. And it took NVIDIA almost 17 years to get to, you know, 7 million users.
So effectively, reasoning models come along. Reasoning models are much more voracious in their token consumption. This is even before we get to agents. This is just deeper thinking than what, you know, one-shot pre-trained models were doing. And so when you looked at token consumption curves, they were just going parabolic. And our hardware, our clouds were starting to break. You know, OpenAI only had 1 gigawatt of compute. Anthropic only had 1 gigawatt of compute. So we had to figure out how to make both more token efficient models, but also more token efficient architectures. So now remember, Cerebras and NVIDIA were big time competitors. NVIDIA and Grok were perceived as big time, you know, competitors. So Sonny, you sent me a text and said, I have an idea. We at the time were major shareholders and still are in NVIDIA, and good friends with Jensen, and you had an idea. And the reason I want to point this out is just like how one person's idea, you know, we see these big transactions, but sometimes we don't unpack like that it's just one decision on one day that causes these things to occur. So what was your, you know, you had a vision that was pretty orthogonal when thinking about NVIDIA. Tell us about how that came to be.
Yeah, and you know, Brad, you did lead that email, so that was awesome. But basically, when we were looking at the problem of inference, even as Grok, what became obvious to us is if you started to dissect how inference works, there's first a dissection which happens between, say, prefill and decode, right? And so many people were starting to do that, where you basically, you know, use a separate set of machines for, you know, prefill and another set of machines for decode, and you can basically get some efficiency, or lots of efficiency by doing that. What we further did, and this is like a good lesson for everyone, we further looked at, you know, prefill and decode, and within the decode, we realized that we could disaggregate the decode, because within the decode, there's many different functions that are happening, and some of those functions are compute intensive, and some of those functions are memory bandwidth intensive. And so one of the big differences with Grok over a GPU is GPUs have lots and lots of compute and lots of external memory, which is HBM for them, which is slower. We don't have a lot of compute on Grok chips, we have a lot of SRAM, and that SRAM is very high bandwidth. almost more than an order of magnitude faster. And so typically on a CPU, you'd see that as like your L1 cache. But we have, we have lots of that in our chips. And so when we looked at the problem, and what the email to Jensen was about was basically connecting to their chips via something they call NVLink. So NVIDIA chips speak to each other via a protocol called NVLink, and that allows you to basically not run something on a single GPU. You can run it on lots and lots of GPUs together. I think today we have 72 you can do, and we're scaling up to 576. Grok has a similar protocol, and we've been running thousands of chips together. In fact, we had many models that we were running on 4,000 to 8,000 chips at a time. So basically, NVLink Fusion was a way for us to allow our chips to speak to the NVIDIA chips, so we could take part of the problem, which we knew the Grok chips were faster at and more performant at, and run it there. And the net result of all that is if you take the same footprint of power, you can get 2.5 times more tokens out by basically combining those two systems together, which in today's world of constrained compute is really valuable.
So Sonny sends me a text and he said, I think we can partner with NVIDIA. That in and of itself is a pretty big change, because if somebody's your chief competitor, the idea that you can partner with them is a pretty big change. He said, would you mind sending Jensen, a text? And I'm thinking to myself, man, I'm going to spend some political capital with Jensen. So I need to know that this isn't a crazy idea. And so I kind of sit on it for a week or something. Yeah. And then Sonny texts me again. He's like, have you sent Jensen, that text yet? And so I said, okay, I'm going to send it to him. And Jensen immediately got back to us and said, interesting idea. Let's have a chat. And you guys started working with him. And what was really compelling, I think, to Jensen was you had, obviously somebody had built a competitive chip, but they had mentally thought about how can we produce a lot more tokens together. So what Sonny just said is really important. OpenAI has got a fixed footprint of, let's call it a gigawatt, that they're going to take in September of Vera Rubin's. In one end of the factory goes power and chips. You obviously have the building and all the costs. And out the other end comes tokens, okay? When they bought Grok for the exact same power footprint, for the exact same building, they're now generating 2.5 times the number of tokens. And the constraint we have in the world is power and memory. So if you can double or triple the amount of tokens for the exact same footprint, it leads to an enormous economic outcome for OpenAI or for Anthropic. And so you've seen, as the demand on inference, because of inference time reasoning, and we'll talk next about agents, as the demand for these tokens of intelligence have exploded, and literally we're consuming tens of trillions of tokens now per week around the world, we've had to come up with more power, more chips, more of these inputs in order to produce those. And so it's not just about fast chips, it's also just about fast inference. It's just about the ability to get more tokens into the world in a world that is constrained.
Yeah.
How many days from the time you showed Jensen a working system, how many days from that until him greasing you with $20 billion?
Probably just over a month.
Yeah.
Yeah.
Yeah, 30 days.
Yeah.
And Jensen is like, did they have any competitive efforts going on at NVIDIA?
Yeah, I mean, I think like NVIDIA, and you see it, and we talked about it at GTC, NVIDIA has an ecosystem already of 7 chips and 5 different racks, right? So NVIDIA is no longer making like a GPU. And I think that's what is one of NVIDIA's superpowers, that they've started to look at disaggregating the problem in all different ways, whether it's storage, whether it's CPUs, whether it's compute or networking chips. And so that already exists. So they had already thought about building a decode-only chip and something that was powered by a lot of SRAM.
Right.
But I think sort of it's a good lesson for everyone, like us putting that email in, starting to work together, and building a prototype that was working with their systems was a real proof of concept for them. And in these large systems, making these things work together, making them performant, and this is across 2 different companies with 2 completely different stacks. I think when they saw that we were able to do that, it showed that we'd be a good integration. And the last thing I'll say is we're 2 very different types of companies. I think if we were kind of making a better GPU, there'd be a lot of conflict within NVIDIA after the type of deal that we did. But because we were making this SRAM chip, deterministic, compiler-based, which is completely different than how GPUs work, it's very complementary for the cultures and the engineering teams to come together as well.
How many people in here have used OpenClaw? I mean, that's pretty incredible penetration. I saw a stat, Mark Andreessen may have tweeted this today, you know, that most of the people he talks to are somewhere between $100 and $1,000 now a day on token consumption with OpenClaw. And he said basically the next 20 years of Silicon Valley is going to be producing technologies to drive down the cost of intelligence, right? And so I want to talk about that, Sonny. If we look at the cost of inference, it's dropped by basically 90% over the course of the last year. It's dropped by closer to 99% over the course of the last 2.5 years. So talk to us about the input, like what's driving the unit cost of inference. And if I take a like for like, let's call it a unit of intelligence, whether it's a basic question I ask or whether it's a little bit more complicated question I ask, do you expect that unit cost to continue to go down? And if so, why? What are the inputs to that unit cost?
So the inputs are, I think, the following three major things. The supply chain, right? Like, you know, what can you do across the supply chain, which is, you know, mostly centered around like Taiwan today, you know, TSMC and the different packaging technologies and the lithography technologies that they buy from others. The innovation that your engineers can perform, right? And what I would say is like the, you know, the amount of power you have, right? And so like those are the kind of things we're talking about. And so what we see today is, you know, lithography technology is starting to reach a limit, right? We're not going as fast as we used to, right? And so we're not getting sort of the Moore's law, so we have to exceed that. So we're exceeding that in a couple different ways. We're exceeding that by making bigger and bigger chips. And so if you see that, you know, these chips become quite large now, which is very exciting, but also lead to a lot of interesting issues. Cerebras, you know, as Brad's been talking about, you know, their chips are kind of the size like a pizza box, right? Versus, you know, the CPUs you guys all would have seen. And so there's a lot of energy and technology there. Is like how big of a package can you make and how much silicon can you pack in there? Then there's the innovations. And so the innovations is really where we're seeing most of this work happen, right? Because that's hand in hand with the models, right? You know, we're seeing this really interesting force today, and there was a bunch of stuff that, I don't know if it was leaked or put out there. I think Elon is at the center of some of that, which is they're discussing like these newer models are approaching like 1 trillion to 10 trillion parameters. And those 10 trillion parameter models go back to that first thing I told you. That's in the fundamental flop calculation of how much compute it takes to generate a token. So as fast as companies like us are making better and better technology, you know, through lithography upgrades, through memory bandwidth upgrades, through innovation and, you know, how we lay out our circuits, through quantization efforts, MVFP4 was another one. The models are getting bigger, and then the demand is increasing. So I'm gonna put it back to you. There's this three kind of, it's a cube, but it's really difficult to navigate right now because all the factors are growing in ways which are really challenging. So the demand keeps going up, the models keep getting bigger, and as fast as we're innovating, even if we get a 50x over 5 years, the models and the demand are faster. And that's why we're seeing, you know, this unique phenomenon like H100 prices, if you're building a startup or using them, they're going up, in fact.
Yes. Like one of the things that I think is important for everybody to understand, I mean, when OpenAI and Anthropic started, their gross margins, right, on the businesses were highly negative. Okay, so that's a scary thing to do. Go raise a lot of money, and it basically produce a widget for $1, and you're selling it for 20 cents, and you have a big negative gross margin. But why was that, right? They were going out and they were charging you all to use ChatGPT, or you know, their APIs were charging a certain amount of money. They weren't that capable, so there was only so much money we were willing to pay, right? And 2 years ago, the cost of inference was a lot higher. But the bet they were making is that the cost of inference would come down a lot, and your willingness to pay would go up a lot as intelligence got a lot more valuable. So, you know, I like to think of the first inning of AI was just getting to a place where we could yield answers, right? In code generation, it was basically like autocomplete, tab complete. In the case of ChatGPT, it was like, you know, basically telling a slightly better version of Google. But now we're entering into this phase of action, right? Where agents do things on it. Go build me an app, go build me a website, figure out how to resolve this customer service problem, sell more of my product, find a cure for cancer, book me a hotel in New York. It starts doing things. And when it does things, the amount of tokens it has to consume in order to do those things explodes by an order of magnitude. But the value delivered to the end consumer as a unit of intelligence goes up by 100x. So your willingness to pay goes up dramatically.
Can I add one to that? You know, this week we saw Mythos, which is the unreleased model by Anthropic, find a bug in BSD, which, you know, think about how many engineers and software developers and everyone else and, you know, companies using that have looked at that code. So we've gone to a place where it's doing things beyond human capability.
Correct.
Which is...
And we're in year 3.
Exactly.
We're in year 3. To give you another, you know, like, what's my best evidence to convince you of the value of AI? Well, my best evidence is that Anthropic in the month of March just added $10 billion in annualized revenue in a single month, okay? That is the total amount of annual revenue for Databricks plus Palantir combined. And they added it in 1 month. And they didn't add it because they hired 1 million salespeople, went out to 1 million companies and convinced them to buy their product, right? They added because their product crossed a threshold of intelligent capability that millions of customers around the world said, I have to have this product to make my company better. The amount that Altimeter is spending went up, but millions of self-interested actors around the world independently made a judgment. I have to buy a lot of those tokens, a lot of those capabilities, both Claude Code and Cowork. And the same thing is happening at OpenAI, not quite, you know, on the same exponential in terms of revenue. But I think for me, this was a little bit of an Oppenheimer moment. This was a little bit of the splitting of the atom. Like, we've heard Dario and Sam talk about the exponential or the end of the exponential on intelligence. But the big question was, are they going to be able to afford to continue to build the compute in order to keep up with this? I had this somewhat uncomfortable moment with Sam Altman on my podcast, the BG2 pod, that went a little viral when I asked Sam, hey, Sam, you've made $1.4 trillion of spending commitments, but you only have 13 billion of revenue. So explain to me how that works. Like, how can you commit to spending 1.4 trillion and have 13 billion of revenue? And I had hoped that Sam would make the case that his revenue was going to go up a lot and these were kind of call options and he could renegotiate them. But instead, he said to me, well, if you don't like your investment, I'll buy back your shares, which was not exactly the response I was hoping for out of Sam in the moment. But that was the question heading into 2026. My podcast partner, Bill Gurley, a lot of other people, highly skeptical, saying this is an AI bubble. These guys are spending at rates they're never going to be able to pay the bills on because there aren't people on the other end willing to pay for the products to justify that level of spending. And what happened in January was Anthropic had a $3.5 billion a month. In February, they have an $8 billion month. And in March, they have a $10.5 billion month. That to me said, oh, everything's changed. The product is now sufficiently good that you have revenue scaling on the same exponential as intelligence. So they can afford to pay for the $50 billion per gigawatt to stand up all of these inference factories to produce all this, you know, kind of collective intelligence. Just react to that, Sonny, because our group talks a lot about this. There was a lot of debate in our group and on the All In pod and others as to whether or not this was a bubble.
Yeah, I'd say that.
Yeah, it was delayed, I assume, because they would have given us a reset if that was the case.
There's like kind of a couple things that, you know, maybe the broader world doesn't see yet. One, the models that we see today haven't even been trained on the latest hardware, whether you want it to be, you know, Blackwells or Veras are just coming out, right? Or Rubins are just coming out. So we haven't even seen that yet. And so we haven't seen the capabilities that you get. And so we'll start to see that. I think one of the first ones we'll see is, the stuff out of Elon's Grok, right? Yeah. So that's A. Yeah. So the capabilities you're seeing here are things that were done on older hardware. So that's A. And so when you're inside the ecosystem, you know what's capable and what's coming next, right? I think B, one of the things that is really starting to take off, and I think Anthropic's done an incredible job here, and I think Codex does an equally incredible job on very hard kind of software problems, is that there's not just a chat interface that majority of people are interacting with. It's not just an API, but they've created like a harness around the models, and those